Hello everyone, myself Dr. Feroza D. Mirajkar, and today we will see a 8051 program for BCD count, which is a simple counter that continuously increments a value stored in the memory and memory with a delay between each increment. Okay, so here this is the program for the BCD up count. First is the initialization, that is org0000h, which will tell the assembler that the program starts at memory location 0000h. Then you have move a comma hash 00h, which initializes the accumulator with value 00h, that it will clear it. Then it next is move 30h comma a. This instruction will store the value 00 in the RAM location 30h. After that, we have the infinite loop for counting. So this red color font, this is the infinite loop for counting, where it will call a delay subroutine, that is up colon a call delay. After that, you have add a comma hash 01h, that is the contents of the accumulator are incremented by 1. Then you have DAA, that is decimal adjust for BCD format correction, where it will adjust the accumulator if the result is in binary coded decimal format. Then you have the uh, move 30h comma a instruction, which will store the updated result of the accumulator in the 30h memory location. Then you have s jump, which is called as the unconditional jump. It will jump back to the label up. Then you have a subroutine, delay subroutine, which we have called in this infinite loop counting, that is a call delay. So this delay, here the first instruction is move r2 comma hash 0 ffh. So here we are loading the register R2 with 0 ffh, that is 255. Then you have up R3 comma hash 0 ffh. So here in move R3 comma hash 0 ffh, we are loading R3 with 255 again. Next you have up 2 colon move R2 comma hash 0 ffh. Again you are loading R4 with 0 ffh. Then you have up 1 colon djnz R4 comma up 1. That is, you will decrement R4 until the loop will decrement R4, and it will continue the loop until R4 becomes 0. Then you have dj nz R3 comma up to, it will decrement R3. Okay, it will decrement R3 and it will jump to the label up to until and unless this R3 becomes 0. Then similarly you have djnz R2 comma up 3, it will decrement R2. Okay, and if it is not 0, then it will jump to the label up 3 until and unless it becomes 0. That is R2 becomes 0. Then you have return, which will return from the subroutine. Okay, and here this program it uses the nested loop structure, and it will create a significant delay. Then this return RET, okay, RET, it will return the control to the main loop. Here it will control the return the control to the main loop. Now we will see the how this DAA instruction is used in this program. So here suppose you are having, now first we'll see what is DAA instruction. So DAA is decimal adjust after the decimal adjust after. So here this instruction, it will convert a hexadecimal number into the decimal equivalent after the addition, and the computations or the calculations in the microcontroller all are performed in the hexadecimals. So now we'll consider an example, that is 09. Suppose if the current count is 09 with no correction, that is using DAA, the next count will be 0A. Okay, like this. That is, we will add 1. Yes, no? DAA. After that, what we are doing here? I'll show in the program. So here, decimal adjust after correction. So here, suppose we are having 09 in the accumulator. Okay, that is 0 0 0 0 1 0 0 1. Now to this, if we add 1, okay, we will get the answer as 0A. So when you add this here, the lower nibble you will get it as 1010, and this will be 0000. Okay, but with the DA decimal adjust instruction, decimal adjust after instruction, the 0A is converted to show 10 in the accumulator. Okay, once you execute the DAA instruction, it will show 10 in the accumulator. It will not show 0A. Now how this is done? So here what we'll do is, to 09 we are adding 1 to get the next count, that is 0A. Now the DAA instruction, it will first check the lower nibble. This nibble it will check, okay, of the result of these two addition. Now the number 0A, sorry, now here in this case, this number, okay, 1010, it is greater than 9. So what we have to do is, we have to add 06 to the lower nibble. That is, we have to add 06, that is, to the lower nibble we are adding 6. It is 06. Now when you add this, you will get it as 10. That is 000. This will be 0. This will be 0 because carry will go here. Then again you will get 0, and you will get this carry will be transmitted here to the upper nibble, and you will higher nibble, and you will get 0001. Okay, so what did you get now here? It is 1 and 0. Okay, now in the accumulator it will reflect 10 instead of 0A. We will consider another example. I'll take 99, which can be written as 1001 1001. Now to this you will add 1. When you add 1, you will get what? You will get 9A. That is, if you add these, you will get 1010, and here you will get 1001. Now it will check the lower nibble, that is, it is greater than 9. So because it is greater than 9, it will add 6 to it. Okay, so when you add 6 to it, you will get like this. That is, you will get A0. This is A and this is 0. You have to add this 0, 0, then you will get 0 here. Carry is transmitted. Again carry is transmitted 0. So here 1 and 1 will be 0. Carry is transmitted. It will be again 1 and 1 will be 0. And here you will get 1, 0, 1. Now it will go for the upper nibble and it will check. Now again the upper nibble, that is a higher nibble, it is greater than 9. So what it will do? It will again add 6 to the higher nibble. So here we will add 6, 0. So 6 is 0110 and 0 is 0000. So it will add this and you will get it as, here the sum is 0. Here also it will 0 and it will generate a carry 1. So what you will get in the accumulator? You will get 0, 0 in the accumulator when it reaches 99. Okay, this is how your DA instruction works. Now here the overall working of the program is, here you have a initialization process. Okay, so now the accumulator and the memory locations, these are set to 0. Here accumulator is set to 0, then that value is copied to the memory location. After that you have the main execution loop where you have a call delay, then you have an increment accumulator, then you are using a DA instruction adjust for decimal, and you are storing the result in 30H. And this loop it will run indefinitely. Then you have a delay subroutine where you will be using the nested loops and the decrement registers, and you will end the program. Okay, So this program, it will function as a slow BCD counter which will continuously increment the value stored at the RAM location 30H, and the DA instruction, it will ensure proper BCD formatting, and the delay subroutine slows down when the counting process to make it observable. Okay, so now we will see the execution of the program. So here I'll copy the program. Now we will go to Keel software. Go to project, new Vision project. I will use the previously used project. Yes. Now search for 8089. Directly you can search for 8089 instead of going to the searching of microchip. 8089 C51. Okay. Then no. Now go to file, new file. You can type your program here. I'll directly paste the program. You have to save the program. What it is BCD up counter .asm. Save. Now go to the target, right click on the source group 1, then click on add existing files to group source group 1 and search for your program. It was BCD up.asm. Select that, add and close. Now click on this plus symbol at the source group 1 and check whether your program has been added. So it has been added here. Now go to the project, click on build target. You can see here there are 0 errors and 0 warnings. Now we'll go to debug, start or stop debug session. Okay. Here at the memory window, we will enter I:30H. Okay. I'll take this here. Now you have to run the program. Run. You can see here there is a counting. Okay, it has started from 1 and it is incrementing 1 by 1, that is 21, 26, 27, 28, 29, 30. It will increment up to 99. Okay. Then after that, it will start with again 0. You can see here the values, here the digits are being changing. Okay. 70, 73, 4, 5, 6, 7, 8, 9. Then you are getting the number in 80s, 90s. So as soon as it reaches 90, 99, again it has started from 1. Okay. This is how your BCD up counter works. Thank you.